Okay, this is Algebra 1, second semester, and as you can see at the top up here, this is the lesson I'm going over, linear regressions and residual plots. And I'm going to show you how to use the onboard tools to get this problem done because there's no other way to do it. And once you realize how to use the tools, it makes things a lot easier. I was thinking originally that you could do all of this in mathway.com. Whoops. And I don't think you can. I started playing around with it, and I don't think you can without paying for it. But if you type in mathway.com, Mathway, I use the graph a lot. It looks like it defaults to a graph. But anyway, um, it has a bunch of stuff over here that you can do. You type in problems and it'll solve it. It's limited, obviously. It wants you to join and become a member. Pay a subscription. I don't know how much it costs, but it's up to you if you do that. But in this particular case, I realized that it wasn't going to work. But just so you know, I think what's coming up is linear system of linear equations, and you can do a lot of that here. So you just type in the linear equation, however it's given, and it graphs it for you. And when you do systems, you can do multiple equations, and it graphs it for you, and you can zoom in and zoom out. And for that, you're going to look for where they cross it. Okay. Anyway, that's Mathway, but it's not going to work for this. But I did discover that they have a calculator that works pretty good. Hopefully it'll work right. I was having a little trouble getting it to where it would show up all the way. This is my second attempt. So here we go. All right. Before I get started, I just wanted to remind you guys that you can click on the lesson. And I know you don't want to do that. You just want to get her done. But sometimes you've got to slow down and go review stuff. So yes, this lesson is kind of lots of words that are like, what the heck are they talking about? And then when they're talking about how to use I mean, this is all great, but this doesn't help us with how to do the problem here. And then they tell you how to use your graphing calculator if you have a TI-83 or TI-84, but most of you don't have one, and you can do most of the stuff without one because you have a scientific calculator on board. And to be honest, this is pretty involved as well. But anyway, and also it has examples. I really wish you guys would take advantage of these examples, especially if you're struggling. Read through it, try the example. It doesn't count against you, and it might help you do a better job on the thing. Okay. I wanted to show this right here when they're talking about correlation, because these problems, a lot of them want to know, is the correlation strong? And it talks about using the interpolation, and will my prediction be reliable? Right? So it's strong. I've used interpolation. My prediction is reliable. It's moderate to weak. I've used interpolation. Then it's far less. So it depends. If the correlation is strong, prediction is good. Correlation is weak, prediction is not so good. Right? If the correlation is strong and I have to use extrapolation, then my prediction will be far less reliable. That extrapolation is a fancy word for best guess. Okay, interpolation is that you can basically use you can use the graph actually and read off the graph or the equation for the regression line. So interpolation is using math. Extrapolation is basically guessing. Okay, and then the worst of all is you have a weak correlation, period, and I extrapolate. I mean, this is the worst. You don't want to use this to get data. So go to the lesson, take a screenshot of this, and you can get, this should help you get at least one of the parts of all these questions correct without doing math. Okay, that's the lesson. Now then, so we've got this data, okay? And 9 times out of 10, if they don't tell you, I mean 9 times out of 10 they're going to tell you. But I think I was looking at a problem where they didn't tell you which one was the X and which one was the Y. But when they do a table horizontally, the top numbers are always the X, and the second column or second row is always the Y if they don't tell you. Now then, I will tell you that once you open this calculator and start needing these values, it's going to cover up some of them. So you would do good to either take a screenshot or write down the last few numbers because you're not going to be able to see them. So I'm going to do that right now because I think I'm going to start. I think it covers up this part. And you'll see here in a minute, but I want to save time by writing this down. 70.7 and 51.8. And I'm just writing down from about here. So I'm writing these down. 11.7, 14.8, 1.9, 7.5. Oops. Make sure you don't get off when you write them down, because then I'll get wrong answers and then you'll think I'm crazy. Okay, I think I got it. Okay, so what you're going to do is you're going to go over to calculator. And you're probably just used to this regular calculator and you're like, well, what's over here? But if you go up here and you go down to statistics, that's what linear regression is statistics. Click on that. And this was a previous plot I had from a previous problem, and I was having trouble with it moving, and it's now giving me the same trouble. It's like when I'm videoing, it won't work. That's just annoying. It's like when that's seriously what the problem is when I'm videoing, it's not letting me get right here and move this. Oh, I got it. I don't know what I did, but I got it. Okay, so this was the previous problem that I was working on, so I'm gonna change this out. I'm just gonna delete this. Okay, so when you open this up, it probably won't even open up the scatter plot. Let me see if I can close this. Oh, don't want to do this. Okay, doesn't want to do that. All right. So when you hit on the calculator, do the statistics. Unless you've already started, it'll open up this spreadsheet. Okay, this is called a spreadsheet if you're not familiar with it. Okay, and what you're going to do is you're going to put the x values vertically here and the y values vertically here. You do not have to label them, but I'm going to kind of help you see where I'm getting the numbers. Okay, so we're graphing pirated downloads versus incidence of malware. So the pirated downloads, the top row is the X. So I'm just going to put X because I'm not going to type in pirated downloads. And then I'm going to put Y for malware. And then what I'm going to do is I'm going to copy each one of these numbers in the same order, only I'm going to go down. Okay? So I'm going to start with 41.5. And all you have to do is just click on the cell that you're typing in and just type in the number, and you can hit enter, and then you just type the next number, 59.1. You can also use your down arrow. Next number is 75.4. Okay, you can use your mouse to click the, whatever you want to do. It goes really quick if you're good at typing, and you could just hit enter, and it just keeps going down. All right, where was I? Okay, so the next one is 33.6, 65.3, 61.8, 57. And then, okay, and then 66.5, and then 35.3. And then I wrote down the rest of them because we can't see them right now. But if you need to see them, you just do this little arrow up here. It closes it, and then you can see them. And then to go back to a calculator. Great. All right. I don't know what that was. Okay, so I was at 35.3, so next is 20.1, and then 70.7, and 51.8. Yep. It's going to give me that error again. Nope. All right, this is supposed to be a Y. I don't know why. Huh, why won't it let me do a Y? All right. Okay. You don't need to put the X and the Y. You don't have to. It's not required. It'll still work. I'm just doing it so you know where I'm getting these numbers. Okay. All right. So now I'm going to start. I keep pointing to the screen. You can't see it. I'm going to start with the first number here. Make sure that these numbers correspond, that they're right next to each other, just like they are here. So 2.7, 5.1, 14.7, 9.6, 5.2, 13.8, 11.7, 14.8, 3.5, and then I wrote down the rest, 1.9, 7.5, 11.9. Okay, so you want to make sure all these numbers line up. Okay, if you got one off, then you need to fix it. If you accidentally skip one, all right. If you type in these numbers and then you keep getting the wrong answer over here, make sure every single number is right. You didn't accidentally add a zero or transpose numbers. Okay. Okay. Once you have that in, you're going to highlight it. So you're going to come up here, you're going to click on this cell, and you're going to hold down your, what's that, left mouse key, and you're going to select all of this. 11.9, okay? Once you have that highlighted, that's the data. You're going to hit this thing right here. This is a chart icon. Okay? We're doing regression, linear regression. So we want to click on this. Okay, now then, let's see if I can grab this thing and move it back over. I just need to be brave. Okay, so when you click on that regression, it's going to plot all the plots, and it's going to do the trend line here. Down here on the regression model, make sure you click linear. Okay, I think it defaults to that, but just make sure, because our lesson is linear. Okay, so these are all the data points. I think you can move this over more. Yeah. Okay, and this is the line of best fit, the trend line, and this is what this equation represents. Okay, so that's how you do that. Now then, the first question asks for the correlation coefficient between these two variables. Now that is not on the graph, but we can find it when I do this. There we go. Okay. So you see this little fuzzy arrow over here on the right side? All right. If you don't see all this stuff here, then you click the arrow, okay? I'm not sure what this copy and export. I guess you could do it. You could copy it to somewhere else and export it somewhere else so you can look at it. I don't know why it keeps popping up. But anyway, what I want to do to get the correlation coefficient is click on this thing right here, show statistics. See, it's this funky little backwards 3, that's the sum symbol. Show statistics. Click on that and it shows me, whoops, all the math. I really wish this would go away. Okay, so all the math that you ever wanted and a whole lot more. Okay, so none of this really means anything right now. You don't really care about it. We're not going to talk about it. I mean, obviously you know what this is. So you remember this if you have to find mean. It's an easy way of finding mean. But anyway, all you care about is the little r. This little r right here. Is the symbol for correlation coefficient. Okay? Now notice it wants to get the answer into 2 decimal places. Notice it is in 4 decimal places, so we're going to use rounding rules. Okay? So we look at the 3rd decimal place, 5 and up, round up, less than 5, leave alone. So it's going to be 0.61. And it's positive. Sometimes they're negative. Okay? So we're going to type that in here. Maybe if my mouse doesn't, there we go. So 0.61, 2 decimal places. Let's see if we're right. Okay? All right, now notice also the sign of this right here will tell you whether it's positive or negative. Okay? So unless it looks like a stop sign out in the country, what I don't know. I used that analogy a lot when I was in class. Let's look at this again. Looks like it's always going to default to your scientific. So remember, just go back to your statistics and that'll show up. So, I mean, the dots are kind of following this line, right? And it's going up, which is why our correlation coefficient is positive. So this is positive, okay? And I mean, there's kind of the same number of dots on the bottom of the line as there are on the top, okay? So that would be, it's going to either be a moderate or a strong positive. And I'd say since there's about the same number of points on top as there are on bottom of the line, and they're relatively close to the line, I'm going to say strong. I might be wrong, but let's see. I was wrong. So I guess because of the spaces between them, I guess if these dots were closer to the line, it would be strong. So I'm going to try moderate, and hopefully I'm right. Otherwise, we're going to, yeah, right. Okay, so it has to do with that. So let me look at the graph again. So the closer the dots are to the line, the stronger the correlation is. The further away, the more space there is between the dots and the line, that would be moderate. If there was just a humble jumble, whatever, like I said, stop sign out in the country, that everyone is shot at as a target practice and it's kind of all over, that would be weak. All right, because it goes up to the right. It's positive. If you can't remember that, it's positive because this is positive. If your correlation coefficient was negative, then it would be negative. All right, moving on. Now it wants you to use your graphing calculator or technology to find the line, the regression, the least squares regression line on X. In other words, what is the linear equation of this red line? Well, it gives it to you right here at the bottom. Make sure it says linear. I think we're fine, but just make sure it says linear. So here's your equation. All you got to do is type that in. Now then, watch out. It only wants 2 decimal places, so use your rounding rules, okay? So it's just going to be 0.17, and this is going to be 0.67. So you're going to type it exactly as it is right here. Y equals 0.17x minus 0.67. And yay, got it. Okay, then for this question, use your regression line to predict the number of computers in a thousand that you would expect to be affected by malware. Okay. Oh, let's pay attention to, they give us two numbers here. Let's pay attention. What you're going to do is you're going to plug one of these numbers into this equation and find it. So predict the number of computers in a thousand. Let's go back up here. Okay, so see the Y is instances of malware per thousand computers. Okay, so that's why. So this thousand is nothing. Okay, all right. It's wanting you to find Y, and Y is in this scale. Okay, but what would you expect? And so what you're looking for is the words, what would you expect to be affected if this? So 80% of the downloads were pirated. Now that's a percentage. Let's see, let's go back up here. All right, all of these numbers are as a percentage. So this is like 41.5%, 59.1%. So we don't have to convert anything. We're just going to take this 80 and plug it into this here. All right, I can't write it down on a piece of paper because I'm videoing my screen. But if I go over here, and so I'm going to take 0.17, I'm going to multiply it times the 80, right? And then I'm going to subtract the 0.67. Okay, so all I did, over here, and I use this equation, and for the x, I replace the x with 80. And it gives me this wonderful fraction. Not really. Enter. Oh, I guess I hit the little approximate. There we go, 12.93. So I'm going to enter that down here for my answer, 12.93. And we're going to submit this step. And we got it. Okay? All right. Now then, this is the one I told you about. We're in the lesson. The lesson it talked about the 5 different cases. Okay? All right. So we have, let's just look for keywords. Did we have a weak correlation, moderate to weak correlation? Well, yes, we had a moderate one. Okay. Interpolation is strong. We did not have a strong. We didn't have a strong. So these two are out. Okay. Did we use interpolated or extrapolated? And now I'm like going to go out on a limb here because I'm thinking be interpolated because it's linear. You interpolate if stuff is linear. If it's not linear, then you have to other methods of guessing. Extrapolate. So that's what I'm going to do. I'm hoping I'm right. And I was wrong. Well, poop. So it said it was a weak, moderate, due to a moderate or weak correlation. Unreliable due to moderate. Very unreliable due to extrapolation. Well, I'm just going to start guessing now. All right, so I disagree with that, but that's what it is. So I must have my interpolate. I'm like really tempted to do another problem, but I don't want to go through all this. I'm sure this video is already long. Let's go back to the lesson. Okay. I'll go. So I need to go to my next problem. How do I go to my next problem? Oh, continue. Sorry. It's not like I do this every day like you guys. Okay, I'm going to go to the lesson. Let's look at that again. That's how. Okay, so here we go. So it's talking about making predictions. So we plug the number in the linear equation, and then we have to determine whether it's reliable or not. Okay. Ah, maybe we should have looked at this. Mrs. Bird, look at your notes. All right. Interpolation means you have used an X value in your prediction that is within the available range of data that you are working with. Suppose the X values range between 35 and 98. So any X value within this range would be considered an interpolation. An extrapolation means you use an X value that it's outside the available range of data. Okay, got it. You got it? All right, how do I go close this? How do I go back? Can I go back to this one? No, I can't. Oh, dang it. Oh, okay. And because I'm not a student, it's not going to save it. Oh, we don't want to see people. Okay, edit task. No, not edit task. Task. Okay. Sorry about that. I'm trying to learn how to navigate. Okay, good deal. Okay. So, extrapolation, if the number that they give us predict is outside our range. So I'm looking up here, and the biggest number is 70, right? The smallest number is 20. So the range is 20 to 70. I don't see anything greater than 7, or there's a 75. Okay? It gave us a number 80, which is outside this range. Outside this range. So because it's not within these numbers, it's an extrapolation. If they would have given us 65, well, that's in this range. Okay? So that would have been an interpolation. Okay? If they would have given us 5, well, there's no number that small. That would have been extrapolation. If they would have given us 45, well, it's in the range. Okay? So that's how we picked that. So it was very unreliable because we had to extrapolate. The number was outside the range and it was a weak correlation. So I'm going to end the video now because I know it's long, but you can at least go back and watch it over and over again to figure out how to do this. So remember, the key is, let me go back over here. The key is to go to the calculator, click on statistics. When you first do it, it's going to open the spreadsheet. You enter the data. The X's go in A, the Y's go in B. Then you hit the chart. You click this little symbol because this is what we're looking for, a regression. Okay? Well, you got to highlight the chart. You got to highlight the numbers. Whoops. Whoops. I'm just going to throw in numbers. Just highlight the chart too. Got to highlight the numbers first. My bad. Sorry. Click the chart. Click here. Okay? Make sure that you click the linear. Okay? It gives you the equation that you'll need later on. You click this funky little show statistics, funky little backwards 3. It gives you all these numbers. You look for the R. That's your correlation coefficient. Okay, if it's positive, it's a positive correlation. If it's negative, it's a negative correlation. If, okay, how do I go back to the graph? Go to the graph. Probably get rid of this, turn this off. Click. If the dots are far away from the line, it's a weak to moderate. If the dots are really close to the line, let me create really quick numbers. Whoops. Good grief. Can't type. Goodness. There. Look at that. Beautiful. Okay. Maybe I should like make some 5. There we go. Okay. So if the dots are really close to the line, that's a strong correlation. If there's big spaces between them, that's a moderate to weak. The bigger the space is, the weaker it is. Okay? So I hope this helps. Let me know if it doesn't. Talk to you later.